The Feynman diagram shows the changes that occur during the beta minus decay. Okay, so the first thing you got to do is you got to figure out the quark constituency of a neutron, right? You should have memorized that, but look it up. If you need to use your Google machine, that's fine. We're just going to totally use any source we can to do these take-home tests, right? So look up the quark constituency. This is some kind of quark, and it decays to a different kind of quark. Okay. So fill those in. Just look up the quark constituencies. You should have these memorized, by the way. You should know what a neutron is, what a proton is. Okay. The second thing is you gotta figure out what this particle is that causes this weak interaction, right? And there's two flavors of it. There's a W plus and a W minus. I'm going to give you a clue. The mark scheme doesn't say that you have to include the plus or the minus, so you can just put a W in there. Right, and then this is a beta minus decay, right? If this is the anti-electron neutrino, then why you got to mark what that is, right? But don't say beta minus. You got to say what particle a beta minus really is. Okay, so if you don't know what a beta minus actually is, use your Google machine and look at your notes. Okay, you should know what a beta minus really is, but that's okay. Okay. And then these things need arrows on them, right? So this thing is either going to go forward in time or backward in time. Remember that matter is drawn on Feynman diagrams. So these are matter quarks, right? Notice that you know that this thing's going to be a matter quark. That's matter, okay, because it's going forward. So matter goes forward. This is time, by the way, the past, the future. Right, so time goes this way, right? Matter goes forward in time. Antimatter goes backward. So decide for all these things, right? You don't have to put an arrow on the W, right? But for this one and this one, you're going to have to put an arrow either on this end or this end. On this one, either that end or that end. Don't do both. Don't do that, right? That's wrong. Okay. And you got to decide if it's a matter particle, it's going to go forward in time, so it'll be going to the right. If it's antimatter, it'll go to the left. All right.